We will do a small introduction in Catalan about Felix, but the whole conference is going to be held in English. Thank you, Felix, for your time, and thank you for joining us in this series of lectures. And I introduce you in Catalan, and then we can continue in English. Donava les gràcies a Fèlix. Fèlix Hilger va estudiar Enginyeria Civil a l'ETH de Zúrich, l'Escola Tècnica Superior Federal de Zúrich, i va escriure la seva tesi de màster sobre el tema el material d'excavació com a nou recurs de construcció per a Zúrich. Al llarg d'aquest màster, en Fèlix ha tractat molt la qüestió de la sostenibilitat de la construcció i s'ha donat del seu interès i que es vol enfocar cap al disseny i desenvolupament de projectes i de les seves propietats, perquè en aquestes fases encara hi ha moltes més oportunitats per donar al projecte una direcció sostenible i innovadora. L'any 2019, en Fèlix Hilger va fundar l'EMAC AG, que és l'empresa amb la que ells treballen juntament amb Lucas Baumann. És una empresa constructora que es dedica principalment a la construcció sostenible amb argila excavada. Gràcies a aquesta tasca professional hem tingut el plaer de conèixer tant en Fèlix com en Lucas fa un any a Lausanne per tal de desenvolupar una façana en un edifici a Lausanne que es construirà amb el material obtingut de l'excavació del soterrani del projecte. Des de 2017, Fèlix Hilger treballa amb Bolshauser Architekten AG a Zúrich i des de la tardor del 2018 és assistent de recerca a la càtedra de Roger Bolshauser a l'ETH de Zúrich, a l'Escola Tècnica Superior Federal de Suïssa, a Zúrich. Felix, well, I hope I've done it the best I know. Thank you very much.
It sounded very good.
Okay,
as far as
I hope.
As far as my Spanish goes.
It's time for you to go. Thank you for the patience. And I'm very sorry for this delay. Disculpeu-nos a tots per aquest retard. Hi havia dos teams a la vegada funcionant, però deixem en el Fèlix presentar. Si us plau, si podeu apagar micros i càmeres, us ho agraïm. Moltes gràcies. You go, Fèlix.
All right.
Okay, it's working.
Okay.
Thank you.
Perfect. Thank you, Miguel, for the invitation and for being able to show a bit what we are working on in Switzerland. As far as I understood, Miguel, he mentioned my three professions that are combined over the material, excavation material. So yes, I have this own company going on called LEMAC. I'm still working part-time with Bolshauser Architekten in Zurich. Roger Bolshauser is fascinated about this material, and therefore I'm also one of his scientific assistants at ETH Zurich. Rammed earth, but also other earthen materials. I will check a few backgrounds why it is interesting to work with this material. I will talk about challenges and maybe also some innovations that were lacking over the last 150 years. Yeah, ask everyone to switch off the microphones. I hear myself double, which is quite disturbing. Thank you. Is everyone switched off?
I think it was the room. I think it's now switched off.
Okay. All right. I will give some historical background and talk about the displacement and during the industrialization of this material. I will talk about the material properties, what we can see in Switzerland of this material, and how we work with these materials. Also, I will show 2 contemporary projects in quite some detail. And I think questions are better done at the end, but if you have urgent questions, always ask them directly. We always start with our presentations with this picture. It is part of a very important wall, and it's done in earthen materials. It's still standing up until today, and you can see it from far up, from airspace even. It's the Chinese wall. The Chinese wall is done partially in earthen materials, of course burned on the side, but also filled with rammed earth and some parts only earth. And what we always like about these images, when you're not taking care of your building anymore, and it goes back to nature and does no harm, then it's a good thing. And that's how we like to go into this topic of earthen building materials, as they do no pollution to the environment. Earthen buildings are surrounded around the world. We also like to show these Chinese examples, where we have these round structures with very old structures with this massive roof and then an earth wall in between. And in this structure, which is also good against opponents, up to 300 families were living in 3 or 4 stories on top of each other. And it shows a very good principle that you need for resistant earthen buildings. You need a good roof on top and a good foundations at the bottom, and then your earthen building will resist a very long time, and as these ones are also standing up until today. Earthen building materials are surrounded on the entire globe. Still 1/3 of the population on our planet is living in earthen building houses. And therefore you can only not find it in China. You can also find it, of course, in Africa, of course, in South America, but also in parts of Europe. The white dots are UNESCO World Heritage buildings, also surrounded in the world. And so I also did a short research in Spain. I'm not a earth specialist for Spain, but as I was talking to you, I wanted to at least show you some buildings that are reliable to you. And apparently parts of the Alhambra are in rammed earth, and I hear often people speaking about it. I haven't been there, so I only found this picture in the internet. I also found a documentation where these 2 very bad pictures were shown. This is a project or a building using adobe or not burnt bricks in earth. And this project in the near of Valladolid is using rammed earth. I'm sure there are people that know much more and much better, so I don't want to go too much in detail. I just wanted to show that it's also a building material that was used in Spain. We are much more related to France, as it is much closer, of course. And in France, this building material was used after the French Revolution, when where a lot of houses burned down and people hadn't had money to build a lot, but they were able to use the local resource, earth. So these buildings are from the late 19th century. and still standing today. We all photograph them and put them in the book, Rammed Earth, Tradition and Potential. And yeah, still, again, you can see here the good roof and the good foundation, and in between you have the unburned original material. Also massive structures still standing today. The people are not very proud of this material. We wanted to go into this building, for example, but the owner was like, why do you even photograph our house? Why do you want to photograph it? But we were fascinated about the long liveness and the dimensions of these buildings. But not only on the countryside, also parts of Lyon is built in rammed earth, here held by this massive structure to prevent the house from destabilization. So parts of the cities of Lyon is built in rammed earth. Lyon and this part of France had a very close business relation to parts of Switzerland, to the east part of Switzerland, over the textile industry. And this is why it is assumed that this building technique also came to Switzerland, with the difference that the Swiss people were hiding it more because they wanted to show that they have built with something else. Here you can see a rammed earth house, but with a lot of stones for the openings and for the corners, and to basically faking that this house is built with stone. But originally it's built with rammed earth. Also, you have structures like these in the east of Switzerland, very massive structures. This is the highest one. It's 5 stories high and completely built in rammed earth. Back then, there was already some literature about it. Mr. François Cointreau, a French engineer and builder, wrote this book about how to build with earth. And he has put down a lot of information so that everyone can build with it. And you can see also that buildings are, according to these plans, very closely built and still standing up until today. We also, in the book, in our rammed earth book, we basically translated Mr. Cointreau into the modern language and used his plans and his information and his also descriptions about tools and the formwork, and together with students. We also built then this formwork and built according to the informations of Mr. Cointreau, and it's still working up until today, of course. This is a formwork that we have rebuilt after the descriptions. Yeah, but from this time and from with the beginning, this is 1850s and late 19th century, cement came into the industry, and it was something new, and it was something that made possible a lot of things where we are sitting in today even. So concrete got developed massively, but it started from the knowledge of rammed earth. As you can see, the formwork and the process of the first concrete is copied from the rammed earth. But then it was a material that was not sexy anymore. It was not it was not modern, and the concrete and all the other building materials were modern, and the only people that built with earthen material were people that had nothing else, and people that had something else wanted to show it, and therefore this material got put more and more to the side. Yeah, why should we build with these materials today? It's a matter of energy. It's a matter of resources that we are using on this planet, and it's a matter of these parameters that has this resource. And yeah, our world, I think, is changing, and we see that every year, at least with these pictures in the news. I mean, this is far away, and it's often in USA, where these massive storms get created, and I think year after year it's getting worse and worse, and the destroyments are getting worse and worse. But not only far away, also for us here in Switzerland, we see changes. This is an example from the mountain area of Switzerland, where more and more the permanent freezing of the mountains is getting less and less due to the warming. And all of a sudden, huge events like this, where whole mountains break down and yeah, destroying valleys can happen. So it's not only somewhere else, it's around the globe some changes, and due to our consumery of energy and resources, and therefore I think, and that's why I work with these materials, we have to change a bit. And yeah, with using earthen building materials, you could save up to 90% of energy during the production. So this, I'm sorry, all my papers are mainly in German, as I'm barely speaking English or have English presentations. So this picture is basically, but you can see the numbers. Earth is using 10% compared to brick or concrete when it comes to the energy during the production of the building materials. And that means when you build actually a house with these materials, you can you can cut off the energies during production by half. So the Haus Rauch, the famous Haus Rauch by Mr. Bolzhauser and Martin Rauch from Lehmton Erde, used half of the energy during the production of this. Also, when you compare it, of course, to other building materials, it's very little. It depends on what you compare it with. It's also a matter of a resource. Around the world, we use a lot of resources, especially concrete. And in concrete, you have a lot of sand. So we have a sand scarcity around the world. We even have sand. We use as much sand as water. So imagine yourself drinking a bottle of water. You can also imagine that at the same time you drink this water, the amount of sand is getting thrown into the building industry. So this is quite heavy, and a lot of structures are built, especially in China. This is said. China used in 3 years, from 2011 to 2014. China used as much sand as the USA in the complete 20th century, so in 100 years. And this leads to a lot of problems. Here you can see people digging sand at rivers. Also, they have to dive for sand in rivers. A lot of people die because it's not safe how they build tunnels or how they dive. And you even have mafia structures to get this output of sand. And then a lot of illegal stuff is happening around sand. And what do we do in Europe, or especially in Switzerland? I'm guessing it's not much different in Spain. We throw a lot away, a lot of material away. We have a city called here Bauwerk, and from this city we have a lot of output of excavation material. and that goes mainly into landfill. I will show this in a few pictures. This is Monday morning north of Zurich, where you have a lot of gravel pits. And in these gravel pits, the material of the excavation material of the city gets thrown away. So you see a lot of a lot of trucks with excavation material on, and they even behind this little hill here, they're standing in line to throw this material away to get it out of the city. And this is how it happens. They unload it up there, then they are this material gets dumped by caterpillars here, and at the front this gravel gets extracted for the concrete that goes back to the city. So it's a crazy amount of processing connected with this material. Why is this happening, or what is happening? Our planet is always the same. It has three main layers. The horizon A, where our plants and our animals are living and we are hanging out, is the Mother Earth. And under this Mother Earth, that is, depends where you are, maybe 5 to 30 centimeters thick, you have a horizon B. And in this horizon B, you have all the granulometry mixed. You have clay, you have silt, you have sand, and you have gravel. And this vary from place to place. And the material that gets thrown away in these disposal areas is a material that consists of more than 10% of clay and silt. If the material would consist of less than 10% of clay and silt, it would be economically interesting for the companies to wash the sand and gravel out. But up already, when it's more than 10%, it's not interesting to wash the sand and gravel out. But that means also for these materials, you throw a lot of sand and gravel already away, only when there's 10% of clay and silt in this material. So, and the green line, for example, depending then on the how much of clay, silt, sand, and gravel you have, but the green line, for example, would be interesting to build rammed earth with, for example. And the black line or the gray line here with a lot of clay and silt would maybe be interesting to do earth plaster out of it. So this is, depending on the excavation you have, you could use it for building with it. And this is what we do. We analyze these materials that we find on site. So we sieve it and we separate it and look how much of each of the material is inside. And then we, with local contractors or corporations, here we were in China for goat houses. We produced a lot of different mixtures with the local material. And then you can find some parameters or some mixtures that are more or less suitable for rammed earth. It's always hard to compare then these parameters to other building materials, but of course I have to. But to understand at least what this material is about, and then to be able to build with it. It cannot do the same as concrete, but it's also important to understand that concrete cannot do the same as earth. So it's always a bit hard to compare materials also with wood or something else. It's a resource that should be used, and therefore we have to understand it, and therefore we have to compare it. So it can only take 10% also of the pressure loads. It can basically not take any flexural strength. That's why we cannot really use it for take for ceilings, for example, load-bearing ceilings. It is a much softer material. It has a higher shrinkage. It creeps more under a consistent load. It has a bit of a better thermal parameters and almost the same density as concrete, or the same density. But as I said, it also has this natural breathing possibility. For example, so this is an advantage. You see a simulation of a house and a relative humidity in this house. So the red dots is a house with earthen building material, and the blue dots is a house that has no earth inside. And you see a house that has earthen building materials is much more stable in the room climate and its humidity. So you would also need less energy to keep a nice atmosphere in your building. So why should we build with this material? As I said, it's a waste product, therefore easily available and cheap. The material itself is cheap. You could save long disposal routes, and you could substitute other building material that have a high gray energy content. It is a natural building material without any chemicals. It generates therefore a special indoor climate by absorbing and releasing moisture. Also, smells and toxins are absorbed and kept. So when you can basically throw your stinky clothes on the floor, and the next day it's fresh. And it has, due to its high density, a good heat storage. It can be easily used for different properties, as a wall, as floors, and in different ways. And yeah, it has a special aesthetic, various colors, and a lot of possibilities that I will show in the following slides. Some natural colors that we find in Switzerland, depending on the part of Switzerland where you are. The red one, for example, is from the Basel area, also the yellow one. Grayish is more in the mountain area. Some samples of us for walls and bricks, and some other samples for floors. These floors we only wax with or finish with a wax to make it at least a little bit waterproof. Other than that, they're not 100% natural earth, and then sanded. So yeah, we as a company we give these services and applications. We can help you with designing and planning, and then we also execute in different ways in the rammed earth, but also with these earth plates or floors. We also have sometimes the material truss calc in projects, truss line, which is comparable to the Roman concrete, an old way of building more water resistant if it's needed. A lot of earth plastering, and we try to do it in a way that it is imaginable for everyone in the certain style, not in a very organic style, let's say. We also try to build modern with these materials. For example, this picture here is a earth plaster that is kind of white and therefore perfectly suitable for architecture office in Zurich. I wanted to talk about a project that combined all my 3 jobs in the last 4 years, and that was recently published because it was finished last year. It's the Kiln Tower Brickworks Museum in Calm. It started already with a student project at the EPFL Lausanne, where we've built with students this structure, where we've the first time pre-tensioned an earthen wall. You can see here 2 massive screws that are holding this wall on site, and this was the first time copying basically a technique from concrete onto earth, and we were able to show that it works. And with this idea, we kept going at our works with Roger Bolzhauser in Munich, where students had to design a project for this museum. So this is the original museum here, and the students were able to design a museum extraction with rammed earth, and the students Robert and Regina made the best project, and therefore we also wanted to build it, and we wanted to combine it with our technique. And this is what happened. We took this project from the students, and together with them and also other students from that joined later, we developed this project. And it is one massive room with rammed earth all around and a little oven at the back, because the Brickworks Museum is dealing with the history of producing bricks, but is not able to burn bricks anymore because the traditional oven is not allowed to be used due to fire protection. Therefore, it was interesting to build this oven in, and that the bricks can be produced on site again. This is the main purpose. So you have one exhibition hall for the museum and a little oven to burn bricks. This is the top cut through. We have a huge opening at the front. Here again, the hall with no ceiling in between. So we have around 8.5 meters high building with only a top ceiling. So basically a 2-story room that need to be held by these earthen walls. And I will come to why we then use the pre-tensioning. The outside, we stabilized the corners with limestone. We compared to other projects in Switzerland, we really wanted to show the joints. So we have wood in between the elements, and then an opening for the windows, and an opening also for this pre-tensioning. And therefore we produced a lot of corners with earth, and that is a bit tricky due to erosion. That's why we stabilized with lime, with this truss lime. We stabilized the corners, a detail that we also found in historical projects. Yes, coming back to the pre-tensioning, we developed together with the engineers from COAC, the civil engineers, we developed a technique to also make this pre-tensioning happening on this higher building. We basically have on both sides of the building these cables or that go from the top till the foundation and hold our rather small building on place. Imagine the earth would shake and the wind would blow, and we have a rather high and tiny building in one direction, and therefore we have these pre-tensioning cables to prevent our project or our building from falling. And therefore, we needed to adapt this pre-tensioning. We have on top springs, and these springs, as I said, in the parameters, the material is quite soft. And imagine due to the creeping, the material would get a bit less high. You can also imagine the screws that are holding the building are not workable anymore. And therefore, we built in these springs to prevent the pressure on the screws. And we are happy so far. After 1 year, it's still working. And these are on the inside and on the outside. And on each of these cables, you have 5 tons of pressure that is holding our building on place. But this is the case. This would be the traveling of the loads without the pre-tensioning. And because we put more pressure on our building, we are holding the forces inside of the building, and therefore it's not falling. I hope this was understandable. We also dealt with a lot of details. Our building is getting smaller, or the elements are getting thinner towards the top. On the inside, which is here on the left, it is on one level, but on the outside we are stepping back with each element around 2.5 centimeters, and therefore we built in these wood parts. This part is from the production, you will see later, and this part is screwed afterwards onto the existing part, and therefore prevents the water from running down the whole facade. And the water comes from on top, goes onto the wood, and then dropping off instead of coming back to the earth. Yeah, of course, we did renderings and planned a lot further. We also dealt of how to make this whole appearing. Of course, we also have some concrete. We'll come to that maybe later. We also built an earthen model to show it potential sponsors how it should look like. So this is a 1:30 model, and we made plans of how to produce these 91 elements. And together with students in a former concrete production hall, we were able to, this is now the place of Lemak, we were able to produce these 90 elements. It was really fascinating to see the motivation of students. And on a first day, you would maybe do half of an element. And at the end, after 2 weeks, there were 6 to 8 elements going out. We covered them to make them dry on all sides the same, and slowly to make them dry slowly. Then we transported them to the site. As I said, we have the concrete foundation because to prevent it from rising moisture. And then we've put element on element. I will also show a movie later on top of each other. Then we made a break for winter, or due to winter, and in summer also prefabricated the wooden roof, put the roof on the earth. We have inside this oven, the burning chamber of the oven is built with chamot stone, actually from Spain, a very heat resistant stone. And on the outside, we have the Terra block stone, a not burned earthen brick with 3 to 5% of cement. And then we have the pre-tensioning. Here we see a detail. We can measure the pre-tensioning at all times with these pressure Druckmesser, with this pressure metal here, that gives us an oil pressure, and this oil pressure can be converted by a computer to the actual load that is still working, so we can monitor it at all time. And then it was finished last April. You can still see now the greenery is back. The inside is here, but I will show a movie to be more in the film. I'll comment it a bit. So this is this now you don't see the students working anymore because this movie was done a bit later with another project that we did, but the process is the same. Mixing the right moisture and the right mixture. Filling this into the formwork. And you see a lot of labor is still needed for this material. You ram it down with a rammer with air pressure. You always have to measure that you're working according to the plan. We now do also our reinforcement with bamboo, a little bit reinforcement just for the transportation, mainly. One benefit of this material, as it only is earth moist, is that you can demold directly after producing, and you can see directly what you have produced. And then it's also able to move these elements, and after drying, you can transport them to the site. And these are now the elements of the kiln tower. Prevent the corners, strap them really well because they're very heavy. As I said, we have a density as high as concrete. And therefore, this is heavy duty transportation. On this loader, you have around 15 tons of material. And then on site, you put them together. You have to have a good crane person. This is as though it looks like it's not cement mortar, it's earth mortar from the same material, just very soft. And then with some wood assistance, you hold the element in place. And therefore, we were able in 3 weeks with good weather, we were able to put these 80 base elements on top of each other. This is my partner, Lucas. He's the guy mainly in charge for the constructions. This is where the prefabricated roof is coming on, ceiling is coming on. And the structure in between was only to hold everything in place until the roof is on and the pre-tensioning is working. And these is again this detail of pre-tensioning, and these are the guys that are bringing the 5 tons of force on each of the cables with oil pumps. So he's pumping the pressure onto the cables. There you see the computer that converts the loads. All in all, we have, I think, 20 of these cables working on this building. Yeah, also we had to do, of course, some retouching, which is quite easy with this material. You use the original material and then fill the joints with a hammer and with a piece of wood. Yeah, some retensioning, a reassistance of the environment. The door needs to be put in, of course. Everything done in pure steel. We've put oil on to prevent it from rust too much. And then we have the finished product. The windows are done with Murano glass from Italy, also for the lights. Here you see the oven on the left with the not burned bricks. You see the details with the wood on the outside. And yeah, since then it is standing a year, and we are happy that the pre-tensioning is working and the loads are still held by the spirals. Okay, I would still show another project if it's interesting. Miguel, what do you think?
Of course.
Yeah.
Of course, you have. Yeah.
Do we have time? Good.
Yeah.
Maybe just we think that with these materials we are lacking 150 years of innovation, and we somehow need to come up with new ideas or with new ways of building with these materials to make it able to also produce it at a lower price or at a more comparable price. As you can see, a lot of labor is still involved in the original rammed earth. I mean, there are companies like Martin Rauch and Lehm Tonerde in Austria that have a machine, and but it's still a lot of work in the Western world. Work is very expensive, and therefore it is also expensive to build with these materials here. And somehow we need to have innovation to make these materials a bit cheaper and more comparable. And we built a music lab in Bern, in the main city and the capital city of Switzerland. This is an existing building where a former brewery was in. The brewery moved out, and you have a very open space. And a client is building in different usages, and one usage is a music studio. And together with ETH Zurich and the chair of Grammatio Kohle that deals with digital fabrication, the client came to Lemac and wanted to build kind of this structure for his music studio. The client is a company that builds high-end music speakers, and to show these clients these very expensive speakers, you need to have an own room for this, and therefore they wanted to have this structure of a circle structure with 5 meter high and 25 centimeters on top thick and 1.25 centimeters at the bottom, a very thick and high wall. And they wanted to produce it with earth and with a robot. And but you had to use a lot of material for this structure. And then our idea was to come up with another solution to build this self-standing curtain, a structure that is at the bottom, this 125 meter thick, but on top only 15 centimeters thick, and produced with a robot. So we planned it further and made 3D models of how this structure should look. The inside structure there is only for the speakers themselves, and it's not holding the structure around. And then we tested it in our hall. The mock-up wall fell down, but we kept going and planned it further, how it should be produced. And so we would build in 2 stories. After the testing, we also and changed a bit the way of production, not circular, more in elements. And then we were able to actually build it. And it is standing up until today. And it's only 15 centimeters thick structure, completely out of earth or clayish material. And the music studio is opening on Thursday. I'm really excited to go back there and to make some actual pictures. And I also will show a movie about this project, a short one. So yeah, it's again together with ETH Zurich, but with another chair, not the chair of Bolzhauser, with the chair of digital fabrication. We came up with a solution for the mix of this material, and together with the students and with the chair, with a lot of work by them, we were able to produce these elements with ball by ball, let's say. We always produced, let's go back a bit. We always produced one side, then the next side, and then in between, because of the material shrank a lot during drying. And then it was able to dry already a bit on the left side and on the right side. And then we were connecting these pieces in between. We kept it moist, at least the connections, to make good connections for the fresh loads. And we did a lot of measuring. We always had to adapt the model and because of the structure moved a bit during drying, it was a lot of measuring work as well. The door is flexible in height, also because the material might move down a bit. We were able to adjust the door, and then it was finished. It is standing on a foundation that makes decouples the structure from the floor, so it does not take any vibrations from there because of sound reasons of the client. Yes, I think that's about it. I thank you for your time, and I'm very happy to have a discussion and talk about more earthen materials or potentials and problems or possibilities.
Thank you very much, Felix. Was really interesting. Congratulations for the work. Perhaps I could, if you allow me, we could start the questions and then we let other people. But this last project, which is probably very interesting, knowing what the chair of Grammatio Kohler do in Zurich, and also combined with the idea of a material that is sustainable, or that's, I think, a very good combination. And what you said about the innovation that is lacking in this field, no, because somehow the development was stopped, and now we're trying to use this material again. For instance, something very, very, very detailed, perhaps, but is it changing a lot the type of recipe or the type of mixture that you use from one project to another? For example, comparing ham with this project in I imagine it has to be perhaps with more moisture. Can you explain a bit? A bit the differences of so the same material but with different recipe, I imagine, no?
Yeah. As you said it already, it's always depending on what you actually want to build, and also mentioned during the presentation, for rammed earth you still have a lot of stones and sand and inside of the mixture, and you can compare the granulometry of rammed earth to concrete. The only difference is in concrete you have cement as a binder, and in rammed earth you have clay as a binder. And for the music lab example, it was very difficult to have this plasticity, so that you're able to press the material without that the material itself cracks. And therefore we still had to have a lot of clay, but the clay is also not very good because of the material. During drying it will shrink a lot. And this was the challenge in this project, to put down the amount of clay as much as possible, and but it still was quite high. So we used a lot of clay, quite an amount of water, and less sand and less stone or small stones within this mixture.
Compared to the ham, that would be a more traditional.
A lot of but calm is, for example, calm is also an innovation a bit. We were not able. We founded the company Lemark quite short before we were able to produce the elements for calm, and therefore we then produced our own mixture. And this mixture is consistent of clay and also a shredder house. So you can see, when you look precisely, you can see broken bricks, broken concrete, broken tiles, and it is basically a recycled one family house and glued together with
clay.
With clay. Yeah,
okay, that's nice.
Yeah.
Well, I don't know if you want to start on the classroom, or anybody else wants to put a question to Felix.
There are some questions
already in the chat.
But they are in Spanish, so it's not very good. Oh. Besides building regulations, which building technology makes rammed earth easy to build, efficient? I'm not sure if I understand this question correct. Maybe to the regulation part. I don't know how it is in Spain, but in Switzerland it is, you don't really need the regulations as long as you have a motivated team to work with this material. You can work with good you can work with good engineers and people that understood what this material is about and why you use it. And as long as people are willing to take responsibility, you are able to build with it. So you don't really need the regulations.
No, meaning that the regulations normally are quite strict in terms of earthquake, and sometimes even in the Spanish regulation, you could think that the ram earth is somehow banned. Of lack of cohesivity and things like this. I think the question goes more in this direction, but well.
Yeah, but then it's also okay. I mean, you can also do the structure with other materials. It's about using this resource then in another way, or as a filling material. For me, also, earth is not the building material that we should only build with. It's just a resource that we should build with again. And I'm not saying we don't use concrete, steel, or wood anymore. We need these materials. It's just a matter that we build with these materials too much, and we consume too much of resources, and we are throwing away this other resource.
Perhaps Jenny can help us with the chat, because I'm not able to see the chat.
I'm able to see the chat.
Yeah, but if the question is in...
The person is asking, does it require a very specific training in terms of engineers or specialists? I don't think it needs a specific training. It is more that you need to know the material parameters, and either we can give them to you, or we can test the materials. Materials are always tested. Also, concrete is tested, and therefore you could, when you're early enough in the project and you have the material, you are able to test it, whatever parameter you need to have. And then when you trust these parameters and you trust your builder that he is actually building with this material, and you want to take the responsibility, then you're normally happy to go with.
So, for instance, one of the resources that I mentioned in your presentation is the idea of using, perhaps as the project in Lausanne could be done, the part of the excavation material that you normally would move somewhere else, you use it to build your own facade, no? So in this case, for instance, it could be interesting. How do you normally manage? You study a bit the let's say the components of this excavation.
And often in projects, you have at the very beginning, you have people that are responsible of looking at the grounds on the site, and when I'm lucky and I'm early enough invited to be part of the project, we can have a look at the papers which are already there, and then when there is more to be investigated, and when there are, for example, drillings or excavations done in an early age, we can also be part of this excavation and look at these materials that are coming. And then we can also do the first tests and say it is possible to do rammed earth or not, or it's possible to use it in another way, or we mix different excavations, because on one side we have more clay and on the other side we have more stone, and then we mix these two excavations from two different sites, and then we have a good mixture. And it's a matter of being early involved in planning, designing, and then testing the material, the local material. You're very welcome. She was thanking me.
Sorry. Sorry that I cannot help you with the chat.
That's okay. I can do the moderator here.
Okay. Sorry for that.
You can also ask questions by speaking out or doing the chat, as you like.
I would invite the other two professors if they have questions as well, Jordi and Mark. I don't know if they can listen to us or they can open the micro. Sí, Marc, ara us sentim ara.
Yeah.
Gràcies.
Thanks, Felix, for the lecture.
You're very welcome.
Just one question about the first project that you present.
Yeah.
Why do you make the blocks in the factory and not in the building site?
Good question. You have seen the surrounding of this project is very green and a lot of woods and nature around. So we wanted to have the impact as small as possible on site. We have a natural habitat surrounded. We have even protected area around this project, and therefore we wanted to be as short and quick as possible on the site, and also have not much used space. We only had, I think, maybe 400 square meters around the building used to build this building, and we only were there for not even we built this building in half a year, and if we would have built the walls on site, it would have taken much longer, and we would have needed much more space to mix the material and to produce everything.
Is there also an economical reason for that?
It can be an economical reason. With this project, we had a lot of different elements in different sizes in terms of thicknesses, and therefore it was more easier to produce it in the whole. But yeah, normally it's better when you have a lot of the same elements and you can produce them with a high amount of machinery and then bring them on site. But it can also be the case when you already have an existing structure where you want to build something before it. It can also be, but then you also have maybe already half of the formwork on site, and then you can build on site as well. It depends on a lot of different parameters if it makes more sense to build on site or prefabricate. But in a lot of times it makes more sense to prefabricate because you're faster on site.
Hi Felix, this is Mark again, Mark from. you showed 3 projects, and all of them quite unique in terms of the way the material is set, the first 2 were quite similar. You were using this pretense metal structure. This, you said because of it's mainly because of the form of the building, because it's very high. It's very, isn't it? Normally, I reckon you don't need to pretend the structure. Just the own weight makes it self-standing.
Yeah, it's also what one has to understand. This project is also like to be understood as a motivation to innovate this material, and it got publicated in a lot of books and got a lot of prizes, luckily, to make this material aware. People are aware of these possibilities, and we need to think about this material again. But you can build much more conventional with rammed earth as well. It's a very radical way, this building, to gain a lot of recognition.
And in a more conventional building, would you use what would be the size of the blocks?
Also, I mean, you can look at the Haus Rauch. It was built 20 years ago almost, and it is 3 stories high, and it is not pretensioned, and it has to do with other parameters than the building is much more wide in its ground floor, and it also has ceilings in between, so it's a much more stable house in itself. It doesn't need the pretensioning. Pretensioning we are needing because we built a kind of a narrow house, 2 stories high with no ceiling in between. This is why we used this pretensioning.
But if you had to choose a format or a size of the block, like we came up with this sort of standardized size for a brick. But what about a brick or earth brick?
It is mainly the main point is 2 main points. It's the load. You have a density of around 2 tons per cubic meter. So when you build elements that are heavier than 6 tons or 7 tons, then you get massive problems with your crane to place it on site. And it should not build in. Let me use my phone. It should not be built in like this, like a column, because then it can move easily. It should rather be built like this, and it's much more stable to be placed on site. But these are 2 principles that are not very highly built and not heavier than 6 tons, are 2 basic rules, let's say.
Thank you, that's very clear.
So I have another question. Do you organize workshops to teach and learn in situ from your experience? Yes, we did workshops or do workshops with a lot of Swiss universities, and some of them were also where other people were invited, and it was open course. At the moment, we have nothing planned so far. The last 2 years were difficult anyway to do something like this. If we do so, then you will find it on our homepage, Lemac. CH, and if you can also gain experience with us if we have enough work to do. You always you can send us an initial application and then we will have a look if it's possible to put you in somewhere. But this is difficult depending on our projects a lot.
You are recruiting already, eh?
Yeah, I'm trying, but I need to have bigger projects to be recruiting more.
Okay.
And but I also want to mention two. So there's Crater or Amaco in France.
Mm-hmm.
And they do a lot of teaching and also have a lot of videos to have more material information, and they're doing a really good job, and you can also do a lot of workshops there, for example.
You mentioned Crater, which they are in France, and the other one, sorry?
It's Amaco. They are closely linked to each other.
Okay.
As far as I understand.
Thank you.
There's another question. Have you tried to build with 3D printed rammed earth? No, I have not. I have had some talks with different 3D printing companies. The problem is with 3D printing earth is the pure durability of the material. With 3D printing, you use still a lot of water and other chemicals, and therefore it's the problem with drying. And yeah, we haven't had the chance to solve these problems really, or the companies that we are looking or we were in talks with are still using a lot of cement or other chemicals to make it happen in 3D printing. So you have to have a very precise look on what is used there. And anyway, in general, rammed earth is not rammed earth, it's not protected. And for example, in Australia and America, you see a lot of rammed earth building. They are called rammed earth, but there is a lot of cement in these mixtures to make the structures that are shown in these pictures. So you need, as a person looking at these pictures and plans, you need to be really careful on what is pure rammed earth and what is stabilized rammed earth, and therefore you also need to have a look how sustainable or how really beneficial these projects are. As I said, I'm not against other or mixing up with these materials, but you have to have very good reasons to do so. Martin Rauch is only building with earth and says earth is the only thing. I am more open, but it has to be reasonable to use other materials as well.
Are there more questions in the chat? Or
no, not so far.
Are in the classroom, perhaps, Mark or Jordi? Is there any question?
No.
Okay, thank you. Well, I think it was really interesting. I think it's a bit the spirit, if you want, of the course. Try to understand traditional materials that have been used because they have very interesting properties, like rammed earth, and try to see new ways of using them, or perhaps traditional steel, but more adapted to to our current typologies and types of buildings. So I think it was a great illustration of how you can manage to do different strategies with RAM Earth with some very humble material, no? But at the same time, that opens a huge, let's say, a huge number of directions, no, to work with. From No, go ahead.
That's actually it. I'm still trying to manage to work with these materials. That's still also for us very challenging, and to work economically and in all the ways sustainable, economically, societal, and in terms of energy use. So it's a challenge, but it's a nice challenge to stand up for.
Okay, thank you very much, Felix. It was really nice lecture. We are in touch, and hopefully we can see you here soon.
I would love to come, but just for a presentation. I thought for sustainable reasons. It doesn't make much sense to fly to Barcelona.
That's clear. Okay, thank you very much. Bueno, Mark and Jordi, you want to add something? If not, we finish here.
Thank you so much.
I want to add something. Follow us on Instagram and whatever. And, if you have more questions,
now it's the at time.
At time, yeah. Show us your opponents or your friends. It's really about spelling the word of Earth has no lobby. A lot of people say, or Anna Heringer says, and Martin Rauch, they say Earth has no lobby. I think we need to create this lobby.
Okay, so we can contact you anytime, no?
Yes, of course.
Excellent. Thank you.
All right.
Thank you very much.
Have a nice evening, everyone. Goodbye to Barcelona and Spain. Bye-bye.
Bye.